This is beyond the business and what really matters.
Most people think infrastructure reacts to demand. That when demand grows, the system follows. In reality, it works the other way around. Infrastructure is built in advance, it is reinforced before it is needed, it carries weight long before most people feel it. And once that weight is built into the system, it doesn't disappear. It stays in the structure itself, it stays even when the original demand changes or moves away. Over the time, this becomes normal. The system feels neutral. The costs feel unavoidable. But the shape of the system is not neutral at all. It reflects the pressure it was built to carry. This episode is about that hidden shape, about infrastructure that remembers industrial demand, and about how the cost of that memory quietly shifts onto society. At the center of this system, there is a simple imbalance that almost no one talks about. Households pay for access, industry pays for use, but society pays for capacity. That sentence explains more about modern infrastructure than most policy papers. People pay to be connected. They pay for local distribution, for basic reliability, for the networks that bring electricity into their homes. They pay for what they actually touch and use every day. Industry pays for the energy it consumes. More power means higher bills. Higher load means higher payments. On the surface, this looks fair. But capacity works differently. Capacity is everything that must exist before electricity is even used. It is the reinforced lines, that oversized substations, the reserve margins, and the ability of the system to handle large industrial peaks without failing. That capacity is built because industry needs it. It is paid for because society exists. When a factory connects to the grid, the system is usually strengthened far beyond what households require. Lines are upgraded, transformers are reinforced, redundancy is added, and backup is planned. Once this capacity is in place, it becomes part of the shared system. Its cost is no longer linked to the factory that triggered it. It is spread across everyone. Households don't create that need. They don't demand megawatt peaks. They don't require industrial grade stability. And yet, they help pay for it. This is not a hidden conspiracy, it is a design choice. For decades, infrastructure was treated as a public platform for growth. Industry was seen as a public good: jobs, taxes, exports, development. Society absorbed the fixed costs so industry could focus on variable ones. That model made sense when factories were local, labor was intensive, and the benefits stayed close to the infrastructure that supported them. Today, the picture is different. Industry is more concentrated, more automated, and more energy intensive, also more global. The infrastructure is still local, the costs are still local, but the benefits often are not. Capacity stays behind while profits move on, and the bill remains with everyone else. This is why electricity prices rise even when energy itself becomes cheaper. People are not paying for power alone, they are paying for a system built to carry industrial weight. Capacity doesn't appear as a clear line on the bill, it shows up as a higher network, charges, rising tariffs, and costs that feel abstract and unavoidable. Households are not subsidizing factories directly. They are doing that through architecture that factories require. That difference matters because once you see it, the question changes. It is no longer just why electricity is expensive. It becomes the question of who the system is really built for and who is paying to keep it standing. There is another blind spot in the system, and it is even harder to see. Society pays not only for excess capacity but also for energy that is produced and never delivered. Every electrical system loses energy. That is normal. But industrial loads increase those losses far beyond what households create. Large factories pull high currents, create sharp peaks, and push equipment far from optimal operation. Cables heat up, transformers run harder, more energy is lost as heat before it ever reaches a user. This lost energy is not free. It has already been generated, fuel has been burned, emissions have already happened, but the electricity itself disappears inside the system. It never reaches homes. It never powers anything useful. And yet it is fully paid for. What makes this especially uncomfortable is that these losses are not charged to those who cause them. They are treated as system losses. They are averaged out. They are built into tariffs. That means households help pay for energy they never received simply because the system was stressed elsewhere. This electricity could have supplied homes, it could have reduced generation, it could have lowered pressure on the grid. Instead, it becomes waste, not because of an accident, but because of how the system is used. So, why is this waste almost invisible in reports? Because losses are reported as percentages. A few percent sounds small, it does not feel dramatic, but when applied to national systems, those percentages represents enormous volumes of energy and money. Percentages hide scale. Also because reports focus on generation, not delivery. Energy statistics celebrate how much electricity is produced and how clean it is. They rarely focus on how much is lost between production and use. Waste happens in the middle, and the middle is not where headlines live. And another one. Losses are classified as technical. Once something is labeled technical, it stops being political. It becomes background noise, something unavoidable, something no one is responsible for. And finally, because the cost of those losses is socialized, when everyone pays a little, no one feels directly accountable. The system just moves on. This is why waste energy remains largely unseen. It does not look like pollution, it does not look like failure, it looks like normal operation. But in reality, it is energy paid for, produced, and quietly erased by a system designed to carry industrial weight. And once again, the pattern repeats. Industry creates the form of the load. The system absorbs the stress. Society pays for the losses. What often goes unnoticed is that industry does not just use infrastructure. Over time, it quietly reshapes it, not through dramatic failures or visible takeovers, but through a series of technical upgrades, reinforcements, and necessary improvements that slowly change how public systems work and who they work for. You can see this clearly in long established industrial corridors along major rivers, the basins of the Rhine, the Po, the Ruhr, the Mississippi, and the Yangtze have been shaped for decades around heavy industry. Power grids were reinforced to serve factories. Water intake systems were expanded for cooling. Pumping stations substations, and backup capacity were added to keep industrial processes stable. All of this was framed as regional development and economic necessity. And yet, the rivers themselves began to operate on an industrial schedule. Water temperatures changed, flow regimes were altered, ecosystems adapted to production cycles rather than natural ones. Communities living downstream ended up paying higher water and energy bills, while also living with degraded rivers that no longer function as they once had. The same pattern appears in major industrial ports. In places like Rotterdam and Antwerp, energy systems, pumping infrastructure, flood protection, and water management were continuously reinforced to support refineries, chemical plants, and logistics hubs. Ports need constant power, constant cooling, constant protection from flooding, and constant water movement. That means pumps running day and night, grids designed for extreme reliability, and coastal systems engineered around industrial continuity. These changes rarely appear as political decisions. They are presented as technical upgrades, but they permanently alter coastal ecosystems and lock surrounding communities into high infrastructure costs and higher environmental exposure. So, more recently, a new version of the same story has emerged in energy intensive clusters. In Ireland, across Scandinavia, and in parts of Germany, large data centers have been built where electricity appears abundant and clean. These facilities don't only consume power, they demand constant availability, redundancy, and massive cooling. Cooling means water abstraction, pumping systems, heat exchangers, and additional load on already stressed grids. Networks are reinforced to meet these requirements, often using public funds or regulated tariffs. Households connected to the same systems pay for that reinforcement through higher network charges, even though their needs did not change. The infrastructure remains public by definition, but its operating logic becomes industrial. And a similar transformation happens around factories that require wastewater treatment and discharge management. To comply with environmental regulations, energy intensive pumping and treatment systems are installed. On paper, this looks like environmental progress. In reality, these systems often cling to regulatory thresholds rather than ecological ones. Large volumes of electricity are consumed to run pumps and filters. Water is returned to rivers warmer and chemically altered. Aquatic ecosystems suffer, and communities downstream face poorer water quality. Society pays twice, first for the energy that keeps them systems running, and then for the consequences through healthcare costs, additional water treatment, and lost natural space. Across all these cases, the pattern is the same. Infrastructure is modified to serve industrial requirements. Those modifications persist. The costs of maintaining them are socialized through tariffs and public budgets. The environmental impacts are absorbed locally by ecosystems and households that did not choose this configuration. Industry pays for the electricity it uses. It does not pay for how the system had to change to accommodate it. This is why the electricity bill looks the way it does. People are not only paying for energy, they are paying for a network that has been reshaped over time to carry industrial weight. They are paying for reinforced grids, permanent reserves, continuous pumping, and ecological stress that never appears as a separate line item. Public infrastructure becomes industrial by design, even when it remains public by name. And once that transformation is complete, everyone else lives inside it, pays for it, and absorbs its environmental consequences. That is the imbalance at the heart of the system. Industry modifies the infrastructure, the system adapts, society pays. Infrastructure never asks who caused the pressure, it only remembers it. Once a system is built to carry industrial weight, that weight becomes permanent. Demand can move, profits can leave, but capacity stays. Costs stay, stress stays, spread so thin that no one feels responsible. This is not a flaw. This is how the system is designed to survive, and as long as we treat that design as neutral, the ending is fixed. Industry shapes the system. The system hardens, society pays, not once, not directly, but forever. This was Beyond the Business, and see you in the next episode.